partial fractions. Let's do this. Obtain the partial fraction decomposition for x minus 2 over x squared plus 4x plus 3. Alright, one look tells you that the denominator is not factored. But you should say, but isn't this not a quadratic factor? Can't we use the quadratic factor form? No, that can be done only if you cannot factor the denominator any further. The first thing to look for is, can you factor this? What do you think? Yes, because look at the middle term. Middle term is 4x. Now, if you factor it as x plus 3 times x plus 1, I'm sure you are well versed in the art of factoring. You can factor this into two linear factors. That's right. This will be x minus 2 over x plus 3 over x plus 1. Now, this makes it simple. Now, how do you write this now in order to break it down into partial fractions? You must write this as a over x plus 3 plus b over x plus 1. So, because the denominator contains two linear factors, we write it as x minus 2 over x plus 3 times x plus 1 equal to a over x plus 3 plus b over x plus 1. Now, can you simplify the right-hand side by taking the common denominator? What's the common denominator there? The common denominator is x plus 3 times x plus 1. When you take this as the common denominator, see here, a will get multiplied by x plus 1 and b will get multiplied by x plus 3. Alright, let's do that. That will be a times x plus 1 plus b times x plus 3 all over x plus 3 times x plus 1. Now, you have an interesting phenomenon here. This is the left-hand side we are trying to simplify. And by using the constants, this is our right-hand side, which simplified to this. And if you look at the left-hand side and the right-hand side, the denominators are exactly the same. Now, what that means is the numerator of the left-hand side must be equal to the numerator of the right-hand side. Don't you think so? Yes, because that is the property of equality. If the denominators are equal, the numerators have to be equal. And therefore, we set the numerator of the left-hand side equal to the numerator of the right-hand side. X minus 2 equal to a times x plus 1 plus b times x plus 3. Now remember, this is an equation, or it is an identity. In other words, this is true for all values of x. If you put x equal to 0, x equal to 1, x equal to 2, it must be true for all values of x. And so, we can actually use a very clever method. What's our aim? Our aim is to find the values of a and b. Now, we choose an appropriate value of x. Now, remember, we can choose any value of x because this is an equation that contains x on the left and the right. This is actually an identity. That means it is true for all values of x. So we choose an appropriate value of x so that one of the constants will be reduced to 0 and we can find the other constant. Alright, so this is an identity, not really an equation. It's an identity. But what's the difference between an equation and an identity? An equation is true for only 1 or 2 or 3, depending on the type of equation or values of the variable. An identity is an expression that is true for all values of the variable. This is an identity. Therefore, it is valid for all values of x. So we choose a value of x that will eliminate either a or b on the right-hand side. Tell me, what is the value of x that will eliminate a? Will eliminate this term. this term will become 0 when x equal to -1, isn't it? When x equal to -1, -1 plus 1 is 0, 0 times a equals 0. That term gets eliminated. And how will you eliminate this term? By setting x equal to -3. That's right. So, what value of x will eliminate a? We just found out that this term containing a can be eliminated by choosing x equal to -1. So, when x equal to -1, a times x plus 1 reduces to 0. So, let's use x equal to -1 in this identity. Everywhere you find x, replace it by -1. That gives you -1 minus 2 equal to a times -1 plus 1 plus b times -1 plus 3. Now that will eliminate a. It will give you -3 equal to 0 plus 2b, -1 plus 3 times b. And therefore we have the value of b. 2b equal to -3, or b equal to -3 halves is the value of b. Alright, now let's eliminate b by setting this x equal to -3. That gives you, replace x all over by -3. -3 minus 2 equal to a times -3 plus 1 plus b times -3 plus 3. That will eliminate this term, giving you -5 equal to -3 plus 1 is -2, -2a, or 2a equal to 5 gives you a equal to 5 over 2. So we will go to our expression. Look at the right hand side. I have that expression there. Our expression is a over x plus 3 plus b over x plus 1. This a gets replaced by 5 over 2. And b gets replaced by -3 over 2. So what will this become? When a gets replaced by 5 over 2, this will become 5 on the numerator and 2 times x plus 3 on the denominator. Is that right? Then b is negative, we'll make this sign negative, and the numerator will be 3 and the denominator will be 2 times x plus 1. So we have x minus 2 over x plus 3 times x plus 1 is a over x plus 3 plus b over x plus 1. Replace a by 5 over 2 and b by -3 over 2. And look what we have. That would be 5 over 2 times x plus 3 minus 3 over 2 times x plus 1. Now, what you should appreciate is that while it is difficult to integrate this left-hand side, it is very easy to integrate the right-hand side because we can integrate each of these simple expressions one by one. Alright, that's what we will do in this.